So this is a question number 50 which came in GATE 2017 in set 2. The question says the composition of a municipal solid waste sample is given below. Though composition components include one is food waste, paper, cardboard, plastics, garden trimming, wood and tin can. The percentage by mass, moisture content and the energy content are the given corresponding to each component. Now the question says the difference between the energy content of a waste sample calculated on a dry basis and as discarded basis. Okay, so now let's calculate the first of all the dry content and then total energy as discarded. So I will make a table. So beginning with component, okay, followed by percentage by mass, then moisture content, okay, then dry content, okay, then energy as discarded, okay, total dry mass, and the last is total energy as discarded. Okay, so first is food waste. FW I am writing it as food waste. Then paper, then cardboard, then plastics, then garden trimming, and then wood, and then tin cans. Okay. So now given in the question, food waste is 20, 10, 10, 10. Garden trimming is 40 and 5 and 5. Okay. And the moisture content is also given 74, 4. Okay. 1, 60, 20 and 2. So now the dry content we have to calculate. How we will calculate the dry content? If 70% is the moisture content, so basically I will rename the uh, uh, columns 1, 2, 3, 4, that is kilojoule per kg, that is 5, this is 6 and this is 7. Okay, so now if we have to calculate the dry content, means 100%, if 70% is the moisture content, that means remaining 30% is the moisture dry content, minus 100 minus rho 3. If you do 100 minus rho 3, it will 70, that is 30, then 96, 96, 99, 100 minus, so 60, then 40, 80, 98. Okay, this is the dry content. Okay, now energy as discarded, this is given in the question. We will write it like that only: 2500, 10,000, 8,000, 14,000, 3,500, 1,400 and 10. Okay, now we have to calculate the total dry mass. So percentage by mass is this much. Okay, dry content in this percentage mass is 30%. So basically how to calculate? So divided by 100. So column 2, this is a column, multiplied by column 4 divided by the 100. So this way we will get the total dry mass, and total dry mass comes out to be 6 That is 20 into 30 divided by 100. 6, 9, 9.6, 9.6, 9.9, 16, 4, and 4.9. How we calculate the value? This column 2 multiplied by column 4. So see, 20% is the mass. Okay, out of that 30% is the dry content. So 20 into 30 divided by 100 will give you the total dry mass. Now, knowing the total dry mass, after knowing the total dry mass, we have to calculate the total energy as discarded. So total energy as discarded is, here they have given kilojoule per kg. In per kg they have given. However, in food waste it is just the 20%. Okay, here it is given 20%. So basically 20%. So if per kg value is this, then the 20% out of it will be how much? So how we will calculate? Column 2 multiplied by column 5 divided by 100. So you will get the total energy as discarded. So if you multiply 20 into 2500 divided by 100, you will get the value of 500. Similar with the corresponding values will be 1800, 1400, 1400, 700, and 5. Okay, so now if you calculate the total dry mass, it will come out to be 6 plus 9.6 plus 9.6 plus 9.9 plus 16 plus 4 plus 4.9. It will come out to be 60. However, for the total energy discarded, the value will come out to be 5805 kilojoule per kg. Okay, 5805 kilojoule per kg. Okay, so now in question, but they are asking energy content of the waste sample calculated on a dry basis. So it will means the total energy which we have to calculate, the difference in the energy content of waste sample calculated dry basis as a discarded basis would be. So see, on a dry basis when they are saying it means that we have to calculate the total energy when the whole mass is dry. Okay, whole mass is dry, but as of now only 60% of the mass is dry, so we have to calculate for the whole mass, and this for 60% dry mass, the energy total energy discarded is this much, 5805. So using unitary method, like for 60% dry mass, if the energy content is 5805, 60% dry mass, 60% dry mass, the energy corresponding is 585 kilojoule per kg. Okay, then for 100% how much it will be? 100% dry mass, it will be 5805 multiplied by 60 into 100, which will come out to be 9675 kilojoule per kg. Okay, so this is energy corresponding to, this is energy corresponding to 100% dry mass. Okay, now we know the value of the energy content dry mass. The energy content on a energy based on the discarded basis was 5805. Okay, so the difference is, so the difference is equals to 9675 minus 5805 will come out to be 3870 kilojoule per kg. Okay, so again I will repeat. So the composition of the municipal solid waste sample they have given the percentage by mass and the moisture content, and the energy content also they have mentioned as on discarded basis. They are asking the difference between the energy content of the waste sample based calculated on a dry basis and a discarded basis would be. Initially, we calculated the dry content of the waste. After calculating the dry content, we calculated the total dry mass. Okay, knowing the total dry mass, after knowing the total dry mass, we calculate the total energy as discarded. Okay, then from that we found that the for 60% dry mass, total energy discarded was this 5805. So energy corresponding to 100% dry mass will be, so using in unitary method, we calculate 100% dry mass, energy corresponding to 100% dry mass, which came out to be 9675. Then, as the question mentioning about the difference, so difference between the calculated dry basis and a discarded basis. So this is the discarded basis. Okay, so the difference will be 9675 minus 5805, it comes 3870 kilojoule per kg. So the answer will be 3870 kilojoule per kg. Okay, thank you.